Hi, hello. Welcome to my Trigonometry for Beginner course. Now, here we discuss basic concepts regarding trigonometry. And the way to do it is, let me try to introduce to you the right triangle. Now, what is a right triangle? Now, for a triangle to be considered as a right triangle, one of its angle has to be 90 degrees according to ChatGPT. Now, the other two angles has to be an acute angle or less than 90 because as we have discussed before, if we sum all of the angles of a triangle, that's equivalent to 180 degrees. So if one angle is already 90 degrees, then the remaining two that is left has to be has to have a total of 90. Therefore, their values are less than 90 degrees. Now, we have three sides for the right triangle. We have the hypotenuse of the opposite side and the adjacent side to the angle. Now, let me try to elaborate on that further using my note. Now, if we draw a right triangle, so we have a right triangle. Now, again, the condition for it to be considered as a right triangle, one of its sides has to be a 90 degrees angle. Now, if you consider this angle here in this side to be theta, so the angle here is theta, we have a side that is opposite to theta. So here, this is the opposite side. And here, we have an adjacent side. Now you might wonder, what's the relationship of this triangle or the sides of the triangle to the Pythagorean theorem that we have discussed before? Now let me give you a simple and brief description. Now if this adjacent side we denote it as A and this opposite side we denote it as B, then by Pythagorean theorem this side or the longest side we denote that to be, say for example, C. Then C has to be related to the Pythagorean theorem A squared plus B squared, simply because it's a right triangle relation. Now this C now, okay, this longest side is given a special name and it's called the hypotenuse. Okay, so that's it. More or less that's how we name the sides of the triangle. Now let's move on further. Trigonometric ratios. Well, it happens that there are functions in trigonometry that we have to be familiar with in order for us to work efficiently in trigonometry. Now, one of the functions here, and I will list all of the 6 trigonometric functions. Trigonometric functions. The first one is sine. Now, if we have the angle as theta, sine theta is as defined by ChatGPT. As you can see, that's opposite over opposite over the hypotenuse. Okay. Now, as I've said, the opposite side, we designate that as B. Then, the hypotenuse, by the Pythagorean theorem, that's just equivalent to, if we take the square root of both sides, then C has to be the square root of A square plus B square. So that's relatively square root of A square plus B square. So that's how we define our sine. Let's move on further. We define now the cosine function. So let me introduce to you the cosine function. Now, if there is an opposite over hypotenuse, there has to be something like adjacent side over the hypotenuse. And as we have defined before, our adjacent side is A. So this is, the hypotenuse is the square root of A squared plus B squared. So that's it. That's how we define our cosine function. Now let us try to define the tangent function. Now the tangent of the angle theta, that is defined to be opposite side over the adjacent side. Therefore, your tangent theta, we abbreviate it as tan theta, is just our opposite side, which is B over A. Now the fourth function is cotangent theta, and this is defined to be the reciprocal of your tangent. Okay, so what we see in the numerator is the denominator, and what we see in the denominator is the numerator. So that has to be the adjacent side over the opposite side. So our cotangent, we define it as cot. That's the shorthand notation. So the cotangent of theta is A over B. So that's our cotangent theta. And effectively, we can say that our tangent theta has to be the reciprocal of our cotangent theta. And we discussed the fifth one. This one is cosecant theta. So it's this notation CSC theta. Now it's defined to be the reciprocal of your sine. So if we try to take the theta, so we defined it to be the reciprocal of your sine theta. So if it's the reciprocal of your sine theta, then as we recall, if our sine theta is opposite over hypotenuse, then what's on top of it in the numerator has to be the hypotenuse, and at the denominator, in the denominator, it has to be the opposite side. Now, so the cosecant theta function, the hypotenuse is defined as, again from Pythagorean relation, a squared plus b squared. So the opposite side here is b. Secant theta, the reciprocal of sine theta. Okay, so the last one, that is the second function. So secant theta here, that is defined to be reciprocal of your cosine function. So it has to be, here in the numerator, it has to be the hypotenuse, and in the denominator, it has to be the adjacent side, defined by the Pythagorean relation a squared plus b squared. Now the adjacent side, that is defined as a. So again, do not forget that our secant theta, that is the reciprocal of cosine theta. And that's it. That's all the 6 trigonometric functions. Now in the next episode, we will try to utilize all of the 6 trigonometric functions in a specific problem. But for now, that's all, and thank you.